Graphs of logarithmic functions. We've already discussed the fact that exponential functions and logarithmic functions are inverses. We know that when we draw the graph of inverse functions, they are reflections of each other in the line y equals x. So here I have y equals a to the x drawn for a value of a that is more than 1. And the red curve here is a graph of log to the base a of x drawn for a greater than 1. We can see that they are reflections of each other in the line y equals x. Here I have an a to the x graph drawn for a value of a that's between 0 and 1. And I'm going to add to that a log graph with a value of a between 0 and 1. Once again, we can see that they are reflections of each other in the line y equals x. If f of x is equal to a to the x, where a is greater than 0 and a is not equal to 1, remember if a is equal to 1 it's very trivial, it's just the line y equals 1, then the inverse function is log to the base a of x. We can deduce the following properties. So the first function is a to the x, and the inverse is log to the base a of x. But remember, they're inverses of each other. So the domain for a to the x we know is all real values. There are no problems with input into a to the x. That means that the range of the inverse function is all real values. Inverse functions always have this property that the range is the same as the domain. We just switch x and y because, of course, y is the output. The range for a to the x, and we know this because we know that the x-axis is an asymptote, is y is greater than 0. And that means that the domain for the inverse is x is greater than 0. The asymptote is the x-axis, the line y equals 0. Think about what happens if you reflect the x-axis in the line y equals x. It becomes the y-axis, the line x equals 0.